So, hello everyone. Welcome to Geeks for Geeks. Yeah, we are live now. Can anybody confirm in a chat like I am audible as well as visible? Uh, Please give me a +1 in the chat so that I know like I am audible as well as visible to you, so that we can start our analysis. Okay, let me check. Okay, okay. Thank you, Lal Bahadur. Thank you so much for confirming. So, yeah, before starting it, let me introduce myself. So, my name is Nitin Kaplas, and currently I'm mentor at Geeks for Geeks. So, yeah, today's analysis will be taken by me. Okay, so before starting it, let's know like how was your today's contest? Like how many questions you are able to solve? So just share your views in the chat so that I know like how many are doing 2 3 questions. Like today we have the 4 questions, right? Okay, exam set 2. Okay, few 2. Okay, yeah, we have 25 live, right? Okay, okay. So let's move to our question number 1. So that okay, so the first question R is find mod in BST, right? Okay, so let me first share my screen. Okay, so please tell me like my screen is also visible, right? Uh, Please confirm in the chat. Please give me +1 in the chat. Okay, so that I know like I can start. Okay, okay, thank you. So let's start. So the first question is it's a very simple question, right? If you know a little bit of BST, right, the basics of BST, you are able to solve that question, right? So in this question, the question side we are given the root of BST, right, binary search tree. Our task is to find the mod of the given BST, right? So let's understand what's the definition of mod. So mod is the simple value of the node which has the minimum value in the binary search tree, right? So that's the definition of it. So it simply tell you like you are given the binary tree. Okay. So inside this binary tree, you have to find the mod. What is mod? The minimum value in your binary tree is the mod, right? So let's take same example. I hope many of you are able to solve, right? Uh, yeah, those are watching live, they are able to solve. So the first example is 5, 4. This is 5, and this is 4. Okay. After that, we have 6, 7, 5, 4, 6. Here we have 7, and here we have 3 and 1. Okay. Now, if you know the property of BST, right? So its property is very simple. This is your root, right? And this is your left node, and this is your right node. Okay. So the BST property is very simple. Like the root will be less than right, and root will be greater than left. So it's not about the left, it's about the left subtree, right? Whole left subtree, you can assume that, right? A whole left subtree. So if you are at here, okay, if you are at here, so what I'm doing is I need the minimum value. So what I'm doing is I simply create a variable. This is my answer, right? So let make infinite, right? So either this is my answer or in the left direction, right? In the left part, left subtree is my answer. Never we just ignore that part, right? For that, what I'm doing is let's create a while loop. Inside this while loop, what I'm doing is I simply search till my root not equals to null, right? Okay, so either this is my answer, right? Either this is my answer, either this is my answer, either this is my answer, right? So simple. Let's take another example. Like for example, this is, so let's not waste to modify. It's very simple question. Okay, so our answer is this. So what I'm doing is I simply make a answer. Here I'm write the max. Either this max answer is my answer or the root data, right? Okay, so here what I'm doing is I store my answer as 5, update my answer, right? After that, where I have to go in the left part, right? So that's why what I'm doing here is, hey, root, please go into the left direction of it. Now my root is going into the left direction of it, right? Now my root is pointing to this. Again, I compare. Hey, is this null? No, it's not. So again, I go in this case and I update my answer. So answer is 5. And what's your root right now? It's 4. Update this. Again, I go into the left part. Again, I am reaching to this page. Okay, after that, again, I am asking, it's not null. Again, I update my answer, which is 3, right? Okay, after that, again, I go into the this case, right, which is 1, right? Again, I update my answer, which is 1. Okay, after that, what we are doing is, I'm again going to the left part. So it simply tell me nothing is there. Please stop. That's why our stopping case is this. When my root equal to null, simply go out of the loop and return whatever you have, whatever the value you are storing into your answer variable. That will be the minimum element, right? So that's the simple idea to solve this question. Okay, so same code is this code, right? So let's save our time. Okay, so same code we are written here. So just initialize your answer variable as max value and just write in the stopping case and update your answer variable and go into the left part of it. At the end of it, just return the answer, right? So yeah, that's the simple idea. Okay, so what's the time complexity of this solution? So you are just doing the binary search and you just ignore the one half, right? Here you ignore this. When you are reaching here, you ignore whatever you have in this direction. You ignore that part. Okay, again you are here, ignore that part, right? Ignore that part. When you are here, ignore that part. So it means it's a login part, right? That's the time complexity of the solution, right? So yeah, the first question is very easy, right? If you understand, please give me a +1 in the chat. Min as place of max. About right part. So if you know the property of BST, property of BST simply tells us that every value which is in the left part, right? It's a small left part is smaller than your root, and whatever in the right side, it's greater than your root. So I just want the minimum value. Why I'm going into the right part, right? Why I'm going into the right part? If you see here, this is your 5, and all the value in the left is smallest, and all the value in the right side of your root, it's greatest than your root itself. So why I'm wasting my time to search my minimum element in the this part, in the right part? So no need to go into the right part, right? Okay, just save your time because the it's given you, it's not a binary tree, right? It's a BST. It's a binary search tree. Okay, so hope you understand now. Okay, yeah, Nizam, it's correct. What you're thinking, it's correct. Okay, so let's move to our next question. Our next question is geek count. So here we are given a string s of lowercase letter, right? So our target is just to count how many ways geek is present in string s as a subsequence. Okay, so I hope you know the meaning of subsequence, right? So yeah, the we just have to count the number of subsequence of a geek string, right? So let's take this example so that we can understand better, right? How we can solve this. So here we have G double E KS Geeks for, yeah, it's Geeks. Okay. So let me numbering this indexing part. Okay. So if you see here, our target is just count how many times the subsequence of geek came, right? Now, if you see here, this is the first I have, right? It's the subsequence part. So let me write here in the form of indexing part. So if you see 0, 1, 2, 3, it's the first geek you have encountered with, right? Now, let's understand the second part. If you see here, you have this G double E, right? Okay, so GE. So that indexing will be 0, 1. After that, you can take any other EK. You have this EK, right? Which is 10 and 11. So let's move to here so that we can save. So if you see here, 0, 1, 2, 3, right? So 0, 1, 2, 3. We have this geek. After that, what's they take? 0, 1, 2, 11. Okay, let me 0, 1 to 11. So let me update this so that we go in the flow of it. So to 11. If you see here, this you are taken, right? And in the second part, what you are taken? This 11, right? GEEK. Just focus on the indexing part, what I am written here, right? After that, we have 0, 1, 9, 11. So it's 0, 1 and 9 and 11, right? So this is also this 0, 1, 9, 11. Okay, this two, this one. After that, we have 0, 1, 10, 11. Okay, these two values, and just take this E and this 11. Similarly, we have 0, 2, 9, 11, 0, 2, 10, 11, 0, 9, 10, 11, 8, 9, 10, 11. So if you see, focus on these indexing part, all are different, right? If all are different, just visualize these indexing part and check with the help of these four indexing what character, what string you are making. You are making a geek, right? GEEK. So we just need the count of it, right? So how many counted it's 8. That we should have to write out, right? So yeah, I hope you understand what's the meaning of subsequence now, which is not in the adjacent part. It's in the subsequence part. Means the order we need. It's in the left to right part, but no need to it will be the adjacent character, right? It's similar like if you know the LCS part in the DP part, right? Longest common subsequence. Just visualize that part. What's the meaning of subsequence there, right? Now let's understand how we can solve this question. Okay, so there are multiple solutions to solve these questions, but the n square is not summating part, so we just have to solve this under n. Now, how we can solve this? I know that we have three characters: G, E, E, K, right? These four characters we have. Now, let me tell you how we can solve this. So here I am taking a variables. The first variable I'm taking is G, right? So let me write here count. It's 0. Now I have E2 count, which is 0. E1 count, which is 0. And here I'm written the variable name, which is answer. Answer simply tell me how many count you have, right? How many subsequence of geek you have. Now, so what is G? G is simply G, right? What is E1? Let's first understand what's the meaning of E1 here. E1 simply tell you, okay, so you have G, but E1 means single E. So that's why we are written here E, right? After that, what's the meaning of E2 here? E2 means, it means, yeah, you need 2E. So let me write here G double E. Okay, so whenever the K came, it means you are with your answer, you are with your task, right? I want the GEEK, right? So when the K came, what I'm doing is I simply do answer plus plus in that case, right? So you just have to need these four variables. Let me explain again. G equal to 0 means how many G you have. Even means how many GE you have, right? Even you just have to remember even like single E, right? And to make GEEK, I need this, right? So that's why we are making a E2 here. E2 means 2E you have, right? Whenever the K came, it means your string will be fulfilled what you want, right? Just do the answer plus plus. Okay. So yeah, so we are just using these four variables to solve that question. Okay. So let's traverse my loop. So what I'm doing is I simply traverse my loop. So okay, so let me write here. This is simply a for loop. Okay, so you can return in any other thing. Okay, so the first character, it's just a pseudocode. Okay, so don't understand like it's an int. It's suppose it's a character part. Okay, now think about it. When I'm traversing it, I equal to 0. What character it is? It's G. So here I am written. Is this G? Yes, it is G. What you have to do? Just do the plus plus in G part. So I am increment my G part. Now let me write here. What is G right now? G is 1. Okay. Okay. So when I move forward, it's E, right? It's E. So let me write here else if. Okay. Is this E? Yes, it is E. Yes, it is E. Now, please focus here. Like when we have E now, what is my E1 right now is 0. What is my E2 right now? It's 0. So what I'm doing here is I simply update first my E2, right? Which is E2 plus equal to E1. So right now, what is your E2? 0 plus 0, right? That's why it's 0. E2 simply depend upon your E1, right? Because here you have G double E, E2, but E1 is GE. If you are encountered with E, just ask your E1, are you fulfilled? Are you fulfilled? They tell no, I am not. I am not yet. Okay, so it means I am 0 right now, right? So what is E1? Even tell, okay, so even will always increment when E came, right? Right now we have G. E will, current character will be, right? Let me add here. Now even ask from G, are you fulfilled? Have any character you have? Any count you have? They tell yes. How many count you have? It's G. So it means that your even will be even plus G. Now even is fulfilled, right? GE. That's why even count here is G. Okay, so let me erase this part. Okay, so here your E2 is 0, even is 0, even is 1, G is 1, right? Now, when I move forward at I equal to 2, right? Again, it go into the for loop and ask, yeah, it is E. So let me add E2 first. E2 always ask from himself and your even. So right now, even is E2 is E2 plus E, which is 1. What is E1 right now? E1 ask from G. E1 is 1. What is G? G is 1. So 1 plus 1 is 2. Now let's understand. Right now we have GE, right? We are traversing till now. So our character will be this. Our string will be this, right? So let's understand what is E2 here. E2 simply tell us that. Okay, so I have only one count, GE. Now E2 tell two count I have, two subsequence I have. So what is that subsequence? One is 0, 1 and another one is 0, 2, right? Both are forming GE, right? But in the form of subsequence, we just have to count number of subsequence we have, right? Okay, now let's go forward and we have K, right? We have K. Now in the else part, we have to write because it's not only these four characters we have S or any other character we have. So we have to ask, hey, you are K. They tell yes. Simply do the answer plus plus in that case, right? Else simply continue your loop, right? Simply continue your loop. Now my answer will be, let me write here answer. right now is 0. Okay, it's 1 because answer previous answer is 0. Now we are filled with our task. Right now, let when I go forward, we have as no need to go in any other condition. Not needed, not needed. When I have G, simply let me do this. Okay, now when I have G, what I'm doing is I simply add G here. Okay, so what's my, let me add the index 4, right? I just want the count. Okay, so what is my G right now? G is 2. After that we have E, right? When I have E, let me add here E2 is E2 plus E1. What is that? It's 3. So now what is my E1? E1 is E1, which is 2 plus G2, which is 2 plus 2, which is 4. Now let's understand here also, like what is my combination of that. So okay, so G we know that it's 2. Okay, it's fine. What is E2 here? Because I want the E2. At the end of the day, I want E2. Our answer depend upon E2, but E2 depend upon E1, right? Now let's understand what's the subsequence of E2 here. So E2 is simple 0, 1, 2. That's the first case. Now second is 0, 1, 5, and what's the third? 0, 2, 5. That's are the three combinations of E2 we have, right? Okay. I hope you understand now E2. So if you understand the E2, E1 is very simple. Okay, so E1 is just a same logic we have to make. Okay, now after that we are here. Let me add here E also. So when we have E, in that case my G is 2. Okay, my E2 will be E2 plus E1, which is 7, right? After that, what is my E1? E1 is E1 plus G, which is 6, right? Okay, after that we have K, right? We have K. Okay, so similarly you just do the dry run of this case, like in this case we E2 will be 7. If you want, let me tell you. I hope you understand, right? So anyone who want, like I can express that double E part. Please give me +1 if you understood till now, so that I can move forward. Okay, okay. So let's move forward. So see here, my E1 is 6, right? Now you have the 6 count of E2, E2 is 7, right? Now when I move forward, I have K, right? When I have K, again I go into the this case and I'm here. So in this case, here you just have to notice if I do the answer plus plus, it's not correct, right? So here we have to update that part because my answer simply depend upon your E2 part, right? Your answer simply depend upon your E2 part. As I said, if your E2 is this, I have K, so simply tell me like how many combinations you have this, right? So here you just have to update that part as answer equal to answer plus equal to E2, right? Now when I'm here, I go into the else if case of E part, K part, answer equal to previous answer is 1. Let's add what's E2 count, which is 7. So my answer is 8, right? After that we have S, go into the continue part. After that it's finished. Simply return your answer. That simply store how many subsequence of GWK you have, right? So similar code we have written here. So what you have to do, as the question said, you just have to take the modulo of it so that our answer will be in the range. So four variables you have to take: G, E1, E2 answer, right? Just traverse your like string, and if it's G, G plus plus. If it's E, first you have to ask from E1 to calculate E2. Hey, what's your count? So you just have to increment according to that. After that, your E1 will depend upon G, right? That's the flow of it, right? GE is E1 and GEE is E2. So that's why please ask your whichever variable you are dependable, right? After that, when it's k, simple add, because your k will depend upon GEE, right? GEE count will be in the E2 part. So simply just do the addition of it. Else you just do the continue. At the end of it, you have the subsequence of GEEK, geek, right? So what's the time complexity solution? It's very simple. Like we just traverse our for loop, and your time complexity of this solution is simple. Big of n, where n will be the length of your string, right? So yeah, it's very simple. You just have to focus on your main task is this. So let's split this. G is this. This is the count of it. Ge's count will be stored in E1 and GEE count will be stored in E2, right? Whenever your K will came, right? So just ask from E2 how many times you are, right? How many count you have. Just add this at the end, just return that answer. Okay. So yeah, that's the intention to solve this. Okay. So if you guys understood, please give me a +1 in the chat, or you have any issue regarding this. Okay. Okay, Nizam understood. Thank you so much. Okay. Okay. So, guys, I just request, please, if you have any doubt after this session, so just comment it down. We can see that comments, right? And just reply that. If you understood, please give me just comment in a after this video, like, yeah, we are understood that, right? And also, please like this video. Okay, so it's just a motivation for us. You can able to understand. Okay, so let's move to our third question. So in the third question, our question said you just have to count good subarrays, right? So in this case, what you are doing is you are given an integer array, right, of length n, and you just have to divide the array into non-overlapping part, right? Non-overlapping means it should not overlap, right? If you take here, for example, if you have 1 2 3 2, right? Either you are taking 1 3 separate and 2 separate, right? Don't overlap any element in both of the sub arrays, right? So that's the simple idea of overlapping part. Now, a task is to divide the array into non-overlapping good subarrays such that each element of the array must be part of exactly one good subarray, right? An array is called good if the last element of the array is not a maximum element of the array, right? If you see here in the example, we have this subarray 1 3 2, and is this good array? Yeah, it's good. Why? Because the last element of your array is not maximum of all the elements of that particular subarray, right? 2 is smaller than 3, right? It means that particular subarray is the good subarray, right? If you move forward, 5 1 4, yeah, the last element is 4. It's maximum. No, it's not, because 5 is also in that part, right? So it means that both the array are good. That's why, for example, the both are good array, right? But if you see here, 1 2 2, 2 is the maximum of all, right? But yeah, it's maximum of all. That's why in the end of my array, that element is maximum, so that it's not the good array, right? Now 3, if you focus on 3, yeah, it's also the last element. It's the maximum element. Yes, it is the maximum element. It means that a single element, always, it's not your good array, right? Now the third part is, if in the increasing part, never you have the good array, right? So these are the couple of examples of good array and which are not good array, right? Now you just have to return the maximum number of known overlapping good subarray in such that you can divide the array, right? If it's not possible, simply return 0 in that case, right? So that's the simple idea. Now let's understand how we can solve this question. Okay, 1 3 2 5 4, right? Now if you see clearly this example, right, a good array is simply good subarray maximum array, maximum element will not your last, right? It's not the last element. Okay, this should not be the last. Max element not equal to last element, right? So that's the logic of it, right? Now if I am here, okay, so that's not the last. So we just have to find from the this part, right? So is this your array? Because the single element is never your good array, right? Never. Now, when I move forward, is this your good sub array? No, it's not. Why? Because the if I divide this array like this is the last element, and it's the largest element, right? It's the maximum element. So I'm not able to do that, right? Now let's move forward. Is this your good sub array? Yes, it is. So what I'm doing is I simply add one into my answer. Now, if you are using this as your subarray, now the first element is this, right? First element of your second subarray is this. Now, I know that like a simple single element is never a good array. So I move forward and I have another element and I'm asking from the another element, hey, you are the largest in that particular subarray. No, it's not. So what I'm doing is I'm stopping here and add 2, and after that my array will be finished. So what's my output in this case? It's 2, right? It's 2. Okay, now let's move to our next example. We have 1 2 double 3 4 5. So yeah, that's the very simple test case. I hope you know that in that case what we are doing is I am here, it's largest right now. Okay, this is also the largest, this is also the largest. Okay, so this is also largest, this is also largest. My answer is not incremented in that case, right? It remains 0. So we just return 0 in that case, right? So yeah, that's the solution of it, right? Now I'm thinking about it like I just traversed from the start. Is this correct? Now let's do another test case. So let's solve this test case so that we can understand can we traverse from the start, right? So that test case is 623 157 and 47. Let's focus on this. Please understand this test case carefully, right? If you want to understand this question. So here, if you have this test case, now when I'm here, is this a valid test case? Good array? Yes, it is. It is. So what I'm doing is I increment my answer 1. Now the starting point for another subarray is this. Okay, so is this good array? Yes, it is. So my answer will be 2. I want the maximum, so that's why when I get to the minimum element in that particular subarray, I break that and make another subarray, right? So yeah, that's the simple idea. Now, when I'm here, is this subarray? No, it's not a good subarray. Is this? Yes, it is. So I increment my count, which is 3. Now, when I'm here, so it's a single element, right? It's a single element, which is alone. uh, I'm not asking from anyone are you take that element in your subarray, because nothing is left after that, right? And I'm not able to segregate all the elements into different groups. That particular element will remain empty, right? It's not in any other groups. This is the first group, this is the second group, this is the third group, right? This is the alone element which is left, right? So in that case, we are not able to solve that part, right? We are not able to solve that part. Why? Because if you read that line carefully, so you have to divide the array into non-overlapping part, okay? Non-overlapping good subarrays such that here the highlighting part is each element of the array must be a part of exactly one good subarray, right? Please focus on that. I hope many of you are not able to solve that question just because of this line, right? Such that each element of the array must be the part of exactly one, means that particular element which is left 7, that we have to like shift in any other good subarray part, but we are not able to do that, right? Because like my idea is simple, like when I get the smallest element upon within the that subarray, I just like break that part, because I want the maximum count now, maximum good subarray. So yeah, the maximum for, if I want the maximum, I just have to do that part, right? But when I do that part, this remain same, right? It's low, right? So to solve that query, what I'm doing is, so let's do the dry run on this case first. So what's my approach is? My approach is, okay, so let's fix this element which is 7, right? Which this is 7. Okay. Now what I'm doing is, I want, like my intuition is, I searching the like a good subarray from the start. When I'm getting it, I break that loop or break that subarray part. Again, I shift it to another subarray, right? That's my intuition. Same intuition we have to do, but from the ending part, right? Now, when I'm here, right? When I'm here, what I'm doing is, I simply make a for loop of it, right? From the ending part. Okay. Now, suppose that my end point is -1 right now, right? Just focus on this part. Later on, I tell you like what's the end point means, right? Now, I'm searching from this case, and I'm asking, right? If your array of I, this one, right? If this one is greater than your array of n minus 1, n minus 1 is fixed, right? This is the n minus 1. If this is greater, is this greater? No, it's not. If this is greater, for example, here we have 8. Just assume for a couple of seconds. So if this is 8, right, it means that that is your good subarray, right? Yes or no? Okay. So in that case, what I'm doing is, I simply make the endpoint equal to I and break that loop, right? And after breaking that loop, I know that one subarray I have. So in that case, what I'm doing is, I simply make answer 1 because I know that, right? So, okay, so that's a simple addition. Okay, now let's move to our actual problem. So in that case, what is my actual problem is, here we have 4, right? Now I'm asking it, is this is greater? No, it's not. Is this greater? No, it's not. It's not. It's not. It's not. It's not. It's not. Right? Nothing is greater than this, right? So in that case, my condition is also that like every element should be in any other subarray, but I'm not able to do that if I'm starting from this, right? It's violating my property, right? In that case, I'm not able to segregate all the elements, right? So in that case, what is my answer? It's 0. So before making your answer equal to 1, what I'm doing is, here I have to write the checkpoint. If your if your endpoint is 1 I, right? So here I'm written, if your endpoint equal to -1, this, it's never updated, right? It's never updated. Just return 0 in that case, right? Just return 0 in that case. So that's the intention, right? After that, it's very simple. Like we just have to do the similar part, right? Okay. So in that case, my answer is not. So let's make do the dry run for this case for rest of the code. So we have here 1, 3, 2, 5, 4, right? So yeah, this is the case. Now, if you focus on this case, now you understand what's the meaning of endpoint, right? So if you focus on this case, this is your n minus 1. Is this greater? Yes, it is greater. Here your array I is greater than your last element. This make one subarray, right? So I am, what's my endpoint is? My endpoint is 3, right? My endpoint is 3. It's fixed over here. Endpoint equal to I, right? I break that part. I'm asking endpoint equal to -1. No, it's not. So here, after that, what I'm doing is, let me write here, I make answer equal to 1 because I know that if endpoint not equal to -1, I got my first good subarray from the ending part, right? Now my this is this. Now what I'm doing is I'm searching from 1. Why 1? Let me tell you. Now this case I already taken, right? So as the question said, you have to don't include the overlapping part. So if I'm counting it, I just have to count till now, right? So this is my endpoint, right? So what I'm doing is here I'm writing the ending point. You just have to traverse till now, right? Don't go beyond it. Okay. So why I am traversing from 1? Because I know I need the one element, right? I need the one element which is outside. So what I'm doing is here I'm written the max, which is your array of 0, right? I have the max, which is 1. Now I am asking here if your max means this element, if this is greater than your current element, is this? It's not, right? It's not. So here we have to return the if condition. It's not. If it's not, just update your max value. Max value is array of I right now. So what is max right now? Max will be 3 when I am here, right? After that, again I go here because when my I equal to 2, because the endpoint is 3, right? I can traverse here. Now when I am here, is your max greater than your current element? Yes, it is. Okay. So what I'm doing here is I find another subarray, good subarray. I simply do answer plus plus. Answer previous one. For that case, now my answer is 2. Right? My answer is 2. After that, what you have to do is simple. Simple. Think about it. If this you already include in your answer, this already include your answer. For example, here you have something like 6. Okay, 6. You have 6, right? For example, just assume that, right? You have 6. So what's your next max value for the current element? Simple. Your max element is array of, because you already include 2 here, right? I plus 1, right? Your next element will be array of I plus 1, right? Now my max value for another value is 6, right? Because here we don't have 6, right? I just tell you like what's your starting point when you move to our next good subarray, when you are calculate your next good subarray. So max value will be array I plus 1. So what is here your array I plus 1 value? Max will be here, let me update here, max is 5. So it's not effective your answer. So simply when I equal to 3, it's break this loop and simply return whatever you stored in your answer, because that's the count of it, right? Okay. So that's the intuition to solve this. Many of you have a doubt if 6 is there, right? So that will not a case. Just do the dry run by around for that cases. So you understand how this approach is solved, right? How this intuition is solved all the test cases, right? Just do it by your own, right? After that, understand that part also. Okay, like how this approach is working for all the test cases. So that's the simple idea. Let me tell you in the code as well. So yeah, if you have less than 2 n, so that's the base case of it. For example, when your n is less than 2, it means that n will be 1, right? If n will be 1, your sub array ka size will be 1 or less. Nothing is there, right? No count will be there. Just simply return 0 in that case. After that, what you are doing is, as I tell you, endpoint is -1. Simply traverse from the end, n minus 2, and make your maxi element as array of n minus 1. So when your current element is greater, when with your endpoint, simply update your endpoint, right, and break that loop. If your endpoint equal minus 1, simply return 0 in that case. And if that checkpoint you already cross, right, so it means you are encountered with any good subarray. So what's your count? It's 1. Make your maximum value as array of 0. At the end of it, simply do what I am doing in that driving part. Similar, yeah, I am written here, right? Okay, so that's the simple idea to solve this, right? So what's the time complexity of the solution? Okay, so here we are traversing L1, right? And here also we are traversing from one time, right? Yeah, it's not a big of n plus n, it's big of n, right? Why? Because if you clearly see, I just break the loop. I'm not traversing the whole, right? If I encountered with one good subarray from the ending part, right? After that, I also make here a checkpoint, right? I just write the end point. Hey, please, only you have to traverse till now, because after that point, I already traversed that, right? So, yeah, we are using the two loop, but it's not a big of n plus big of n, right? Okay, it's simply big of n. So, yeah, that's the approach to solve this. Okay, so yeah, hope you understand this case. Okay. Yeah, the shit. Yeah, it's a point where I think most of you are stuck. So because that's the case, like this is the main issue, right? Such that each element of the array must be part of exactly one good sub array, right? So that's the issue while we are solving the question. Okay, so if you understood, please give me a +1 in a chat, right? So yeah, my suggestion for you guys is like please do the dry run for this case. Yeah, many of you are have a doubt like why we are traversing from the end. I know that for this case, but is it valid for all the test cases, right? So just do some dry run by around, right? After that, you understand like how we are able to solve that, right? Okay. Now let's move to our next question, right? It's a very much tricky question, right? So it may need very good visualization to understand that problem, right? So before starting it, let me tell you uh okay, so you need one quick summary of this problem, right? Just watch this like recording part again, right? Okay, so let me tell you a bit of it. Simply do the count from the ending part, right? Here we are written the ending part. When you are encountered with, right, when you are encountered with your uh, when you encountered with the part when you have any good subarray, just break that loop, right? After that, just traverse from this case. So in this intuition, you are not able to stuck anywhere. Any element are not left, right? That's a simple intuition. Okay, so let me tell you while solving the next question, right? So yeah, the please focus as much as you can on the last question, right? So it's a bit tricky questions, right? So we have to visualize very much on that particular question, right? So yeah, let's start it. How many of you are able to solve that question? Fourth one, 2032. We are here. Or understand the problem, understand the problem is very easy. Okay, got TLE. Okay, okay, many of you get TLE. Okay, so let's understand first problem. Okay, so it's a bit of like a CP problem. Okay, so yeah, let's understand this. So you want to buy p properties, right? P properties means you just have to find buy the plots, right, on an infinite one dimension road where on each position there will be either a police station or a property, right, which you want. Okay, so let's do step by step. Okay, my drawing is not good. Okay, okay, so it's a 1D dimension, right? So as the question said, either you have the police station or a property. Okay, so let me write here, either we have property or police station. Okay, now after that you are given the integer array station or size n which show the position of the police station on the road. Like my focus is like I just want to buy p properties, right? But the problem is like on the road many police stations will be there, but here we are given the array, right, which tell you that on which position your police station will be, right? Okay, so the array will be given you this 6 and 8. Now here each station I is distinct and its position can be negative, right? That's the problem. Okay. So after that, the price of the property. Let me first make this, right? So that you can understand it better. So let me write here 1 and it may be negative. Let me write here 10 raised to power 8 because the value of negative will be this. The constraint tells us that, right? So we have 2, we have 3, we have 4, we have 5, we have 6, we have 7, we have 8, okay, we have 9, 10. Okay, so we have 11. Here we have the maximum value we have, right? So that will be the constraint part, right? Your constraint part is this. Now, if you see here, NS2 means two police stations will be there, right? Which is 6 and 8. So let me write here, this is the police station 1 and this is the police station 2. Okay, now, so I want P properties, right? Which is 5. My target is to buy 5 properties on that particular road. This is the road, this is the police station, this is the police station, this is the property I can buy, right? My target is I want to buy 5 properties. Okay, now after that, if you let's understand here this part. The price of the property on the road is the distance of the property from its nearest police station, right? The distance is the absolute difference between the police station of the nearest police station and the property itself, right? Now you have to return the minimum amount that is required to buy exactly P properties, right? I want the minimum amount so that I can buy 5 properties, or we can say that P properties, right? Now let's understand what this part tells us that. So it simply tell you like this is the police station, right? And this is the plot number. Just assume this is the plot number, right? So if I want to buy this property, right? If I want to buy this property, how much cost I have to pay to builder? Simple. This minus this, which is 1. So it's the absolute difference, right? As here tell us that distance is the absolute difference between the position of the police station and the property itself. So this is 1. If you buy this plot, it's 2, right? Because 6 minus 4 is 2. Similarly, this is 3, this is 4. Again, this is 1, this is 2. So okay, sorry. It's a police station, right? So yeah, this is 3. Okay, so I want to buy at the minimum cost. So why I'm buying from this? I can buy from this now. Why I'm buy ninth number plot from this police station? Okay, so I can buy from this. I can buy from this. Rest of thing I can buy either. So let me tell you this case. So here the intention is, suppose we have two stations, right? And here we have plots, right? Okay, so if you see here, for this police station, I can buy from this case, I can buy from this case. Similarly, for this police station, the nearest plot is this, or this, right? Okay. Similarly, for this police station, near is this, this, this. So if you see clearly, this is a police station, right? Either I can, I just want the minimum cost, right? I can buy from just adjacent plots in the left direction and the right direction, right? Similarly, when I am here, I can buy from this, I can buy from this, I can buy from this, I can buy from this. So at each police station, just buy from adjacent left part, right part, left part, right part. So that's a simple idea, so that we can buy P properties at a minimum cost, right? That's the question said to us, right? Okay. Now let's understand the dry run part. Okay, so let me make this 6 5. Okay, so I already make above. Okay, so let me clear this. Okay, so clear this also. I want P properties, right? So just focus on that. This police station, I can buy this property, yes, because it's in the cost of one. 6 minus 5. Okay, I buy this. Now, can I buy this? Yes, you can. So what is the cost? 2. Okay. Can I move forward? So let's stop that. If I buy this property, how much cost I have to pay? 3. Again, if I buy this property, how much cost? 4. Similarly, this minus this is 5. So what is the cost? 6, 10, 15. Right? This is the one possible way, right? Okay. This is the one possible way, but it's not the optimized way, so that I can save my money, right? Now, think about it. I can buy this, okay, it's one. I can buy this, which is one, right? Okay, both are okay. Now, can I buy this? Yes, you can. Let me add two. Okay. Now, if I focus here, okay, so let me give you step by step. Okay, so I can buy this, and I can buy this 1 1. So nearest place is this. Can I buy this? Yes, you can. 1 1 1. We can buy. Now, now if I buy any plot which is at the two place from this station, right? So can I buy this? Yes, you can. Let me add two. Okay. Now, can I buy this? Yes, you can. Let me add here two also. So if you focus here, let's focus here. I can buy this, this, and this, and I want only five plots, right? I can buy the nearest police station's plot. So what's the cost I have to pay? One plus one plus one, two plus two, which is seven, right? So that's the output here, which is seven, right? So that also given in the explanation part. You just buy 4, 5, 7, 9, 10 plots. 4, 5, 7, 9, 10 plots, which is nearest to your police station, so that I can pay as much less as I can, right? Okay, so that's the idea to solve this. Okay, so the main idea is, let me add again, 1, 2, 3, 4, 5, 6. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Here we have 10 raised to power 8. Here we have 10 raised to power minus 8. Okay, so minus 10 raised to power 8. Okay, so yeah. So that's the our station numbers. Now, I have a single road which is 1D, right? After that, question said you just have to buy, right? If that two stations are in this form, it's very complex for me to visualize on the number line. So that's why the first step is, if I sort my police station in this increasing order, 6 came first, after that 8. So that will be in the form of number line, or we can say that in the 1D direction. 1D, right? So that's why the first thing is just sort your police station, right? Okay. After that, what we have to think about it is, for example, let's focus here now. For example, your P is 1. So if you see here, you have 6 here, you have 8 here, right? And you just want P equal to 1. Your main target is I just want to buy one plot. So what is your answer? I can buy this, I can buy this, I can buy this, I can buy this. I just want one, right? I just want one. So I just buy 5 number plot or 7 number plot or this plot or this plot. So what is the difference between these two? If I buy or this or this or this, but because the P is 1, it means 6 minus just adjacent value, which is 1, or 6 minus 7, which is 1. I want 1 because in that case I simply return 1. In that case, if my P equal to 1, simply return 1, right? I just buy just adjacent to my police station, so in that case I just simply return minus. Okay, so my 1 in that case, right? Okay, now let's understand like what is the range of it. As you guess, that police station will be in the sorted part, and I have the number line, right? We are solved many questions on the number line, I hope, right? So that will be depending upon one search that is called binary search. Here the my mind tell we can use binary search, right? Okay. So after that, just think about it. Just think about it. Ki, if my value is right, if my value is what is my minimum value, right? What is the minimum? For example, your P will be 5, right? In this case, P will be 5. So what is the minimum value? As you know, like in the binary search, we always use low, high, left, right, right? So in the middle of it, we just traverse that part, right? We just check that part. Similarly, here we also do that, the same idea. But the question arises what is my minimum value? As you see here, the minimum value is 1. Why? Because that plot I can buy, right? That plot I can buy. So your minimum value, or we can say that left value is always 1. I can buy just adjacent element, adjacent plot number, right? This plot number. Okay. Now, what is your maximum value? What is your maximum value? So if we have this case, 5, so I can buy maximum within the range. I can buy plot number 1, right? This is the range part, right? I can buy this plot. I can buy this plot. Why? Because here we have 6 police station, and what is the value of P? P is 6 minus P, which is 5, right? Okay, so it's 1, right? It's 1. Now, what I am telling you is, I just buy that plot which is at farthest as it is, right? So, what is the range? I just want 5 plots, right? I just buy this plot number 1, 2, 3, 4, 5, right? But what is my range here? It's please don't focus upon this part. I just want to like make my mid at that point where I can uh, like uh, make my cost minimum, right? So that is why only at this point. Okay. After that, I'm not able to find this, right? For example, I buy this, I buy this, I buy this. Because my mid is 3, right? Again, in this direction, I can buy till my mid. Again, in this case, I can buy till my mid. Again, in this case, I can buy till my mid. Okay, as I make this like a diagram in the previous part, right? So in that part, what I'm doing is I just want to find this is the closest, right, which is 1. That's why left is 1. Which is the largest, which is the farthest within the range. Okay, I can buy this, buy this, buy this, buy this, buy this, right? I buy these all for five plots, but this is the closest. That's why you are left only 1, right? Now beyond this I can find, no, it's not. In the most case, what I'm doing is I just focus on this police station and only in the left direction. I'm not focused on in the right direction. So if I focused in the right direction, what what's happen is I can buy this. Can I buy this 0? No, because my P is 5, right? My P is 5. So in that case, I'm not able to buy this plot because my P is finished, right? My P is finished. So what is the range? Left is 1 and right is P, right? Right is P. So that's the range. Okay. So hope you understand these two values. So if you understand this, please give me +1 so that I can move ahead. Okay. So yeah, I hope you understand the range, right? Left and right. Okay. So let's first clear this so that we can do the dry run. Okay. Now, I know that my left is my left is this, right? Okay. My right is this. So what is my midpoint? 1 plus 5 by 2, which is this. Now I have the midpoint. I have the midpoint. Okay, I have the midpoint this, right? Which is 3. Let me write here 3. Okay, 3. It means that if you are at here, you can find till mid 1, 2, 3. Again, if you are here, let me make another diagram. So this is the police station, this is the police station, right? So here you have things. So your mid value here is 3. Okay, so you can buy this, buy this, buy this, right? Similarly, if you are focused here, buy this, buy this, buy this. Okay, similarly, if you are here, buy this, buy this, buy this. Beyond you are not able to do because I want the minimum cost. Here also, buy this, buy this, buy this, right? Okay, so that's the intention to solve this, right? Okay, so what we are doing here now, your main work start here, right? So you have to do the dry run. Okay, me and you. Okay, so if you see here, my mid is this. Let me show the code also, like it's a lengthy code. So the first case, I hope you understand it, right? Now, why I'm adding these two values, that is in the range, right? Afterwards, you understand it, why I'm doing that. If you focus here, what is your value of station I? It will be minus 10 raised to power 8 or 10 raised to power 8 max. So you are just pushing that two values, right? After pushing that value, I already understand, like tell you, we have to sort the stations, right? We are sorting the stations part. Now, already tell you like what's the value of left? 1. What's the value of right? It's P, right? Now, your n will increase. Why? Because you are adding two virtual stations, which is minus 10 raised to power 8 and 10 raised to power 8. So that's why what we are doing is n plus equal to 2. Okay. Now I want the minimum answer. I want the minimum answer. So what I'm doing is I just create a variable which is min cost and make long max, right? So I make a variable min cost which uh, like store the value which is max, right? Okay, now what I'm doing inside this loop is I just make the left right combination and find the midpoint, right? After that, so let's understand step by step, right? What we are doing is I just make a variable name which is needed, which is equal to p. This p tell you that like how many plots it's left to buy, right? It's p. So let me create here p. Okay. So yeah, my request again is please focus carefully. If you are not able to understand a bit of it, yeah, you are left with nothing afterwards, right? Now, my mid is this. Okay, my left is this, my right is this. After that, what is my needed part? What is my needed part? It's P. P means how many plots you have to buy right now. It's five, right? After that, what I am doing is I just make a cost which is zero. Why? Because if I make a mid equal to 3 for that particular mid, how many cost I have to pay? That will be zero right now. So let me create here zero, right? Okay. Now, what is my remaining? Remaining is mid. So let me write here remaining as mid. This simply tell you like what is your range from that particular station to go, right? This. After that, you are not able to go, right? Because I am fixing that part. Remaining means free. Again, I am telling you that simply tell you what is your range from the particular station, right? Where you can go left three, right three. Again, in the second station, you can go left side three times or right side three times. That will be the range so that I can make my needed cost, right? Needed part, right? Needed part means your number of like plots which is needed to you buy, right? Which is this. Now, just simply tell like what's the number you already picked, how many plots you already buyed, right? Picked right now is zero because I'm not buying right now. Picked is zero. Okay, hope it's clear. After that, let's move forward. Now, I go in the array because that array will be my uh, yeah police station now. So this is like this. Okay. Now I'm traversing from I equal to 1 less than n minus 1 because this is not my police station, right? I just make this so that I can solve that question, right? Afterwards, you understand why I'm adding this, right? Okay. Now my I equal to 1, right? Now if you see here, when my I equal to 1, what I'm doing in the inside this is pick left equal to remaining. Remaining is 5. It means that if you see here, pick left is remaining means if you are standing at here, I equal to 1 means here or here. You can visualize that part. So what is the range so that you can pick left? Pick left means remaining, which is 3 right now. Remaining means how many, what is your range from that particular station. So pick left means you can maximum pick this, this, right? So in this case, what I'm doing is I buy this, buy this, buy this. So pick left is 3. Pick left is 3, right? After that, if you focus here. So as I already tell you, like what is your picked means? Picked means how many you are buyed. So my pick left is 3. If I am sending here, so now my pick left picked is 3, which is 0 plus 3, which is 3. Because I already buy these three, right? Now, after that, when you are buying these three, you have to pay the cost, right? You have to pay the cost. Now, what is the cost you have to pay for plot number 5? 1. 6 minus 1, which is 6. Now, what cost you have to pay for the plot number 4? 6 minus 4, which is 2. For this 3. Now here you are, these 3 plots you are buying. You have to pay the cost. If you are pay the cost, you just have to add the cost, right? Here I am adding 3 plus 2 plus 1, which is 6. Now, you know that you have to buy 3 properties. One, 2, 3. If this is all also you have to buy it, it's 4. If this you have to buy, it's 5. but here I'm not buying, right? I'm not interested to buy that. Okay. Now, if you buy these three properties, you just have to do the sum of it. Now, you have the n value, which is 3, because you buy three properties. Now, what is the sum of the n natural numbers? Simple. N into n plus 1 by 2, right? That's the formula of it. Similarly, here what I'm doing is cost plus equal to pick left. That's your n, because pick left means 3. Pick left into pick left plus n by 2. That's the formula of n natural number now. N into n plus n into n plus 1 by 2, right? So that much you cost you have to add here, which is 6, because you buy the three plots, right? Now your cost will be 6. Okay. After you buy these three plots, your main focus will be, okay, so in the left direction of that particular station you buy it. Now your main focus is, let's buy in the right direction, because my range is 3, right? My range is 3. Now, when here also your range is 3, right? But if you focus here, please focus here, but only between these two stations. If you buy this, this, this is a police station. You are not able to like buy that, right? Okay. So your range will be 3, but what? How many plots is there? So that's why first you have to find the distance between this. So what is the distance between these two parts? How many plots is remaining in between these two police stations? So what I'm doing is I just make a variable distance is this minus this, which is I plus 1, because right now I'm at I equal to 1. This is I equal to 2. What is the distance between these two? So this is 8 minus 6 minus 1, which is 1. Yeah, we have only one plot, right? So yeah, that's the thing. Here again we have written is distance equal to station I plus 1, because right now I'm at I equal to 1. Station I plus 1 minus station of I, right, which is my current station, minus 1, right? That simply give me 8 minus 6 minus 1, which is 1. I know that, okay, only the one station it is this, right? So I know that distance is 1, means only one station is there, right? Now I just want to pick the minimum of, okay, I have the mid, which is in the range, but what is your this distance? So that's why what I'm doing is I'm written here pick right, because pick left is already done, right? Now what is the pick right is minimum of mid distance plus 1 by 2. Why by 2? That's the concern. Let's focus here now. If you see here, this is my plot, this is my plot, this is my 6. Okay, so don't assume 6. Okay, so this is the case. Now, if I have here this case, 4 plots in between. Okay, I know that the distance between these two is 4, because the plot number is 4, right? We have the 4 in between. Now, if I buy this, okay, I have to pay 1, pay 2, which is free. Now, if I have the 4 plots, can I buy this 3, 4? I have to pay 3 plus 4, right? But but if you divide that part, hey, okay, so I only buy uh, nearby this station, this and this, okay, and this police station, please you buy this and this, so that my cost will be 2 plus 1. Initially it is this, but if I do this approach, 1 plus 2 here, 1 plus 2, this is 3, this is 3, what is this? This is 9. I have to pay much, right? That's why what I'm doing is minimum of mid. Mid is my range. Now, what is the distance plus 1 by 2? That's why, for example, your father have 10 plots. So your brother, you are two brothers, B1, B2. Just divide by 2, no? This, right? So here approach is also the same. That's why we just have to divide by 2, so that my cost will be minimum, right? If I buy, if S1 buy all the properties, right, my cost will be 9. But if I divide by 2, you divide here, okay, you buy this, you buy this, right? So that's the approach, so that I can save my money, right? Okay, so hope you understand why we are dividing by 2. Okay, now when I'm dividing by 2, like what's my left right pick we have? Pick right, which is mid is 3, and here we have d is 1. 1 plus 1 by 2 is 1. So what is I can maximum pick? 1, right? Just 1. Okay, now when I pick this one, I have to pay the money, right? I have to pay the money. Let's move again here. Now distance is this, pick right is this, right? We already understood. Now if I'm picking this, let me add here. So because I already buy this property, let me add into the picked part, picked variable, right? Now I buy 4 property, 1, 2, 3, 4. Now when I buy this property, I have to pay the money. So what we are doing here, cost plus equal to pick right, right? Same formula, n into n plus 1 by 2. Same here, pick right plus 1 by 2, right? So we just have to pay the money. Now again you have to focus here. Okay, so what if you buy this property? Okay, so when you are standing here, you buy within the range this side, you buy within the range, and how many plots you left this side, right? Now when you are reaching here, I equal to 2, right? When you reaching I equal to 2, again you have to buy in the left direction and the right direction. But if you focused when you are at I equal to 2, right? Here we are written I equal to 2. Before going to I equal to 2, I have the range. I know that. I know what's the distance between these two, which is 1, because I already buy this. I'm not able to go and buy again this property, right? Because this plot is already solved, right? Now what I'm doing here is I simply make a remaining, because just remind in the initial part, remaining will tell you like what's your range. Now this part will tell like what's your range. Range is your mid, right? How many plots it's left, right? That will be the range, and the distance minus what right pick already by. Right pick by 1 means this. So minimum of mid is 3, right? What is the distance? Means what? How many plots in between? 1 minus. Okay, you have the one in between. How many right pick? Means this one picked. This one picked 1 because this already by. This will be stored in 1. So let's minus this. What is the minimum between these two values? Which is 0. It means when you are reaching to I equal to 2, right? You have 0 remaining. 0 remaining. Okay, so here we have to write remaining will be 0, right? Again, when this is finished, go into the for loop and I equal to 2. Okay, I equal to 2. When I equal to 2, remaining will be 0. It means that you are not able to buy anything in the left direction of it, right? Because you are at now this station. Okay. After that, what is left pick? 0. What is picked? Picked already 4 because I'm not buying here because I have the 0 count, right? So what is the cost? Cost is 0 because my left pick is 0. Now, here the intuition is like why we are including this. Now, when I'm reaching I equal to 2, now I'm asking like, okay, so I'm already solved this part, right? What is the range? What is the distance between these two police stations? It's very big, right? Because 10 raised to power 8 minus 8 is very big, right? So what I'm doing here is I store into the distance part. It's very big. Let's suppose it's infinite. But I have the range, right? How much range I have to move. So pick right will be minimum of mid or distance plus 1 by 2. Distance, just forget about the distance part here. So what is the minimum here? Means pick right. Pick left is 0, right? Pick right is 3 because your range will be 3. Now, in this case, what I'm doing is I simply buy this property, this property, this property. So, if I buy these 3 properties, right? Pick right is 3. let me add into the picked, because I already buy three properties, right? So here what I'm doing is I picked equal to pick plus equal to pick right? So I'm adding into the pick variable. Now when I'm buying these three properties, okay, so let's add the cost also. So again, 9 minus 8 1, 10 minus 8 2, 11 minus 8 3. Simply it's just like the formula of your natural number. We have 3, so 3 into 3 plus 1 by 2, which is, here we are getting the cost of it. Pick right into pick right plus 1 by 2, right? So what's the cost here? 3 into 3 plus 1 by 2, which give me 6. So again I am adding 6, which is 12, right? Okay, now your for loop is complete, right? Because it's up to n minus 1. Your for loop is complete. And when your range, when your mid is this I equal to 3, you buy 7 properties. 1, 2, 3, 4, 5, 6, 7. And you have to pay cost this. Okay. Okay. So 1, yeah, it's 2, 3, 6, 6 plus 6. Okay. So it's 13, I think. Okay. So yeah, something is issue. It's 13. You have to pay. Okay. Now, when it's 13, right? When it's 13, now, what you have to do here is you go into the if condition. And when you are in the if condition, if your picked is greater than your needed, as I already tell you, like here I am making a variable name needed. Needed equal to P. How much I needed? I need only 5 plots, but I buy 7 plots, right? It means that you have to like sell that part, right? So also I just want to decrease my cost so that I can sell. Now think about it. Like here if you see, I just want to min cost equal to cost minus. Okay, so think about it, which plot I have to sold so that I can save my money, which is farthest from your stations. This, and let me increase the color. This one and this one. If I remove this two, I can save my money, right? Which is two. I buy two more, right? Because my P is 5, so that is 7. If I remove two, I can sell two. What is the distance? Distance from this to this is 3. Distance from this to this is 3. So if I remove these, 13 minus 6, which is 7. That's my answer, right? Now, here needed is how much I needed. Picked means how much you like buy. So if picked is greater than my needed, so what I'm doing is I simply do cost minus mid. Mid tell you like what's your range. Range is 3. This is this. This is my range. This is my mid, right? And what is this? It's a number of plots which you buy more, right? Which is picked minus needed. So here we are written how much you like buy, how much you needed. Just multiply these two values and remove your cost. Now my min cost is, now my min cost is 7, right? Now when my min cost is 7, right? Now like many of you are thinking about why we are doing equal to sign here. When it's equal to now, when it's equal to, so see, when picked minus needed is equal to, so that formula will give you zero cost, right? Cost minus zero, because picked minus needed is both are same. 5 5 for example, 3 3 is 0, 0 into mid is 0, so nothing will be changing in your min cost, right? Now let's move to the next point. When you are picked, when your range is 3, when your mid is 3, in that case your answer will be this, right? Answer will be this 7. Okay, I am storing that. What you are doing in the, like, just visualize that part. When your low is this, when your mid is this, you want the minimum answer. Just think about this. You want the minimum answer. And for example, you take the midpoint, which is 3 right now. Suppose this is 0, and this is 8. Just think about this. Okay, so this is 4. Okay, now you are asking to helper function, hey, this is your answer. Okay, so your helper tell yes, helper function tell yes, this is a possible answer within my conditions, within my rules. Okay, but the question said you just want the minimum, as much minimum as you can, right? As much minimum as you can. So in that case, what you are doing is, okay, I'm storing that mid into my answer, and what you are doing, okay, I just decrement my range, high equal to mid minus 1, right? Now my high will be here. And in that case, what I'm doing is, again I find the mid. Again I call the helper function. Helper function will tell me, no, it's not within your range, right? It's not working fine. It's not working fine. When it's not working fine, this is the if condition. Else case, when it's not working fine, okay, it means this is not working fine. What you're doing in that case, low will be mid plus 1. Now your low will be this, right? In that case, what you're doing is low is mid plus 1 because you need the minimum cost. Okay, you stored into your answer. Already you stored in the min cost, right? When you store in the min cost, go into the left part because you want the minimum cost. So similarly here also we do right equal to mid minus 1. And if you are already picked less, just go into the right side, right? So that you can increase your mid part, right? So yeah, this is the intuition to solve this, right? Now if you see in that case, and mid equal to 3, your minimum cost is 7, right? Okay, now when you increase, oh now when you do that part, like mid equal to 3 is working fine. Now your left is this, right is this. Now your right will be mid minus 1, which is this, right? Again you find the mid, which is this. It means your range will be 1. Your range will be 1, right? Now again when your range is 1, you just do and check all the possibility in your array, right? If you see here, when your range will be 1, again you go into the while loop, the condition is satisfied. Again you find the mid, which is 1. What is your needed? Again, your needed will be 5, right? Because at mid equal to 3, you already computed your minimum cost. That's why you need the needed part, which is 5. Because your P is 5, right? P is 5. Okay, again your cost will be 0. Again you are calculating, okay, so that particular I equal to 1, how many in the remaining in the left part? That will be here. How much you are picked? 0 right now. Again you go into the for loop and find the minimum cost as much as can, right? So that loop will traverse till that case, right? So let me tell you, like I equal to 1, it's not working fine, right? In that case, your range will be 1. It means you are not able to find. In that case, what you are doing is, again you have to go your left will be mid plus 1. So here your left will be, right? Okay, so just do the trial by around. I hope you understand till now, right? Again, your left will be this, right will be this. It means your mid will be this. Again, your range will be 2, right? If your range is 2, just think about it. Okay, so you are here, you buy this, you buy this. Okay, you buy this. Okay, when you are here, you are not able to buy this. You buy this, you buy this. Simply, this is 1, this is 2. 2 plus 1 is 3. Let me add here 3. Okay, in this case, you buy 1 plus add 1. In this case, 1 plus 2. 1 plus 2. In this case also, when your mid is 2, your range is 2, your minimum is 7. It's not updated because already it's 7 when your mid is 3, right? Now, when it's satisfied, again it go into that picked case, right? Picked equal to needed. In that case, your right will be here, go into the left direction. Now your right will be mid minus 1, which is this. And it break the loop, whatever it stored in your answer. right? That we have to return, which is output is 7, right? So that's the intuition to solve this question, right? Okay, so hope you understand it. If you're not understand it, right, please just go again in the recording part, right? I hope you understand, right? Because yeah, it's a bit tricky. You have to watch 1 or 2 times, right? Just do the dry run by around, or not understand why divide by 2. As I already tell you, this part is also I tell you. Okay, so if you have this 6, this 8. Okay, so let's take this another example. For example, S1, S2. Okay, so this is 4 plots. So for example, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. If you buy this and this, what is your cost? 1 plus 2, which is 3. If you buy this also and this also, what is your cost? 1 plus 2 plus 3 plus 4, which is 9, right? And you buy all these 4 plots, right? And for example, this is you and this is your brother, right? And if you eat all the candies, right, your brother will not like take any candies, right? What I'm doing is please split. So if you eat all by your own, your cost will be 9. But if you divide it, this by, which is 3. If this is also by this one, what is the cost? 1 plus 2, because 6 minus 5 is 1, 6 minus 4 is 2. So what is the cost? 3. So yeah, we buy this, your brother will buy this. You buy this, you buy this. So what is the cost? 3 plus 3, which is 6. If alone you are buying, your cost will be 9, which is greatest. That's why we are doing division part. So in that, S1 ka right will buy this 2, S2 ka left, let's remain for that part 2. Now if you have only one, if you have only one, right? For example, this is 6, this is 8, and this is 7. Either this by, right? So if this by cost 1, if this by cost 1, both are similar, right? That's intuition for that. Yeah, it's not difficult, as I already tell you. Like you have to visualize the part, right? So what's my recommendation to all? Please watch this recording part 1 to 2 times and do the dry run at the similar part, right? At the similar time, right? So yeah, that's the part. Okay. So what's the time complexity of the solution? Let me tell you what's the time of this solution is. Yeah, it's n log n, because if you have the left right in this part, we just do the binary search. Okay, so inside this, what I'm doing is I just traverse I equal to 1 to n minus 1, right? Which is n. So time complexity is n log n. And also we are just doing the sorting part. If you see the above code, right, we just sort the stations, right? That will also create n log n. So the complexity of this solution is 2 into n log n, right? Which we can say that it's n log n, right? Okay, so hope you understand the solution. Yeah, we just have to apply this, right? Apply the binary search to solve this. We given the binary tree, and okay, sorry, we given the 1D dimensions, right? And we just have to plot this. Yeah, this is the approach we can solve this question. Okay, so hope you understand the solution. And if you are not able to understand the fourth one, so yeah, again I'm requesting you, please visit this video again, and yeah, do the try and buy around. Okay. We are initializing the two stations because if you see in this case, when I'm I equal to 2 part, When I am at this part, right, what I'm doing is I want what's the distance between these two values. Means after that, what we have, right? Okay, so what we have 10 raised to power 8. That will be the distance, which is very max. Let me write max. Now I have the range mid, which is 3. So that's why we take the minimum of these two values, right? That's why we want the distance, right? Which is 10 raised to power 8. Okay. So yeah, hope you like today's session. So if you have any doubt, you can reach out to me on LinkedIn as well. Right, my link is in this part. It's a unique name. I think nobody is of this name. Okay, so that's it. If you want the code, can I copy paste the code and give it to you? Just do the dry run of this code. Let me give you. Okay. So yeah, thank you so much for joining today's session. Right. So yeah, thank you so much. Good night to all.